Hello friends. So let us discuss some more on the terminologies that we have discussed in the earlier videos. The first one we will discuss here is string. Let us assume that we have symbols alpha and beta. Then how many symbols that we can form of length 1? So for length 1, the only possible cases will be different strings will be alpha and beta. Of length 2, we have alpha beta, alpha alpha, beta beta, and beta alpha. That means 4. Similarly, of length 3, we will have alpha alpha alpha, alpha alpha beta, alpha beta alpha. Similarly, beta 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 till we have 8 different symbols. Similarly, if we have length of n, length of 3, if we have length to form a string of length n, then we have similarly 2 to the power n different string. So let us take another question or talk in a general. Just imagine if we have p symbols, p different symbols, alpha, beta, gamma, something like that, and we have to form a string with the possible length of n length. Then how many different strings are possible? So here, as we have seen earlier, for first length we will have p symbols. That means we will have p options there. Again, for the similarly for the next symbol, second symbol, we have p option, and for third p option, for fourth p option, and for nth we have p option. That means we have p to the power n different strings by p symbols of length n. So second terminology that we have discussed was language. So language is a collection of string. Just imagine if we have alphabets alpha a comma b. This is a symbolic representation of alphabets. Then there can be different languages over that. And just imagine languages like set of all string of length 1, set of all string of length 1, that can be a and b. Another language can be set of all string starting with a, set of all string starting with a. These can be a. Similarly, a b. This can be infinite. So a language can be finite as well as infinite. Let us discuss about more on alphabets. The third terminology that we have used was alphabets. As we know, alphabets can be represented by sigma. So if we have alphabets like A and B, so what let us discuss about powers of sigma. What does it actually represent? First one, like sigma power 0, Actually, whatever power we have here represents the length of that string with using that alphabet. Just imagine we have here sigma is equal to a comma b. So we have to that means sigma power 0 represents set of all strings that have 0 symbol. So we represent that with epsilon. It is called epsilon. Please remember these terminologies. This will be used very frequently. Similarly, sigma power 1 represents set of all strings of length 1, which can be a comma b. Similarly, sigma power 2 represents set of all strings of length 2, a, b, b, and b. Another terminology that we will use frequently is sigma power star. What does it represent? It actually represents set of all strings that can be formed over alphabets, over that alphabet. So here we have alphabets a comma b. So sigma power star means sigma power 0 union sigma power 1 union sigma power 2, similarly till infinite. That means we have a string combination of string sigma a b, b, and so on of all length string that can be formed over that alphabets. So as we know, these we have discussed languages. Languages can be finite as well as infinite. For any language, actually languages are formed by these strings, and if we pass any string over that language, it checks that it is actually present or not. So if we will present read compiler designing, so there is a one phase called syntax analyzer. In syntax analyzer, what does it checks? Actually, whatever syntax you are passing or whatever code you are writing, it checks that that string which you are passing is actually correct or not. So how it actually checks? We pass it to some language, and on the basis of languages we give some input. Some languages is passed and we give some input. So on the basis of these languages, it checks, syntax analysis checks that whether this input is true or false, yes or no, whether it is right or not. Similarly, for any programming languages, this compiler is there, so syntax analyzer checks that. Similarly, whatever machines that we have discussed in the last video, like finite automata, LBA, PDA, and Turing machine, it is used to check whether the input that we are giving will be considered true according to that languages, or it will reject. So that is a fundamental process how actually compiler designing compiler works. So before behind the compiler, actually all the work is of TOC, that is theory of computation. So theory of computation works mechanically. So in the next video we will we'll see partition of theory, or whatever what we read in the regular expression part.